Welcome back to Scholar Strategy, and this is Algebra 2. Last time we worked with logarithm functions, now we're going to graph them. So, these things will have the same shape as our exponentials, but they'll be reflected. So, for example, last time we looked at y equals b to the x, or 2 to the x. And we know that they're going to look something like this. So when we reflect it, this is our y equals log base b of x. So we have a vertical asymptote at x equals 0. Our domain is x is greater than 0, and our range is all real numbers. Because we're just doing the inverse. In the inverse, you switch your domain and range. So this was the exponential growth. And then for values for b as a fraction, that's decay. So remember, our decay graph looked like something like this. Right? If we reflect it over this line, it's going to look something like this, actually. So this is our y equals log base b of x. Vertical asymptote x equals 0. Domain x is greater than 0. Range all real numbers. Okay. So if we wanted to graph some simple logarithm functions, we're just going to rewrite it. So remember from last time, we can change this into base 3 to the y equals x. And then this one would be base 1/2 to the y equals x. And when you're doing these, instead of choosing x values, we should choose y values because it's a lot easier. Because 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. So we're going to write these down. 1, 0, 3, 1, and 9, 2. So we got this going on. If we use negative values, it's going to look like this. Make sure to make it more curvy than mine. It's approaching x equals 0, but never touches. Once again, domain, x is greater than 0. Range, all real numbers. So this one, if we plug in -2, we'll get 4, -1. That's 2. And 0 is 1. You can still plug in any values, whatever you feel like it, but I use those to make it easier on myself. X is greater than 0. Range, all real numbers. And this would be 4, -2, 2, -1, and 1, 0. This one's going to do this. Boop. Alright, here we go, the general form. So horizontal translation, we're still using the opposite. And what it does is it translates the graph left to right. So what if it says plus h, we're moving the graph to the left. If it's minus h, we're moving it to the right. This is still up or down for our k value. So luckily, those really never change. H and k, they always do H is always left or right, k is down. So, for these steps, we're going to do step 1, graph the parent function, y equals log base p of x. Okay. And it says graph, but we're just going to use... I mean, it's helpful if you graph it, but we already have the graph from the previous page. Wait, where'd it go? Oh, whoops. Wrong page. There we go. So we still have this graph here, so we know the general shape. But when you're working on these, you might want to graph the parent function. Okay, and then put out our values. H is -3, and K is 1. Okay, so we have two tables here, and these are a bit more complicated because we have to shift the graph using H and K. We can't easily just put this in our calculator. I mean, we can put this in our calculator, but it's not as simple. So here's the parent function. We had 2 to the y equals x. Okay, because we're using base 2. So this has nothing to do with the x plus 3 or plus 1. This is dealing with the parent function y equals log base 2 of x. Okay. Now if I plugged in values for this one, I would plug in y values. And I would use 0, 1, 2, and 3. Because 2 to the 0 is 1. And then we have 2, and then 4, and then 8. Okay. Now we're going to translate. Okay. We have h is -3 and k is 1. So I'm going to take my x value, so I'm going to take 1 and then -3, and take my y value and add 1. Okay, so my x value is 1. I'm going to subtract 3 and get -2. I'm going to take 2 and subtract 3 and get -1. I'm going to take 4, subtract 3, and get 1. So take 8, subtract 3, get 5. And then my y values, I'm just going to add 1. 0 plus 1 is 1. So 1 plus 1 is 2. 2 plus 2 is 3, and then 4. So our domain is x is greater than 2, and our range is still all real numbers. One second. Sorry. The domain x is greater than -3. So remember before we were doing with exponentials, we had our y always greater than our h value. Same thing here. Oh no, this time, no, we had y is greater than k. So since we're reversing our domain and range, we're looking at the x values, and the x values deal with h. So x is always greater than our h value. So for domain, x is greater than h. But dealing with logs. Alright, and then we just graph this. So we don't need to graph the original one unless we want to. So I'm just going to graph the actual graph. So -2, 1. -2, 1. -1, 2. And 1, 1. Or 1, 3. That's a 3. and 5, 4. And since the graph is being moved to the left 3, our vertical asymptote is now at x equals -3 instead of x equals 0. Okay, let's move to the next one. So the parent function, we're using 3 to the y equals x, because this is base 3. So I'm going to plug in values, 0, 1, and 2. So I get 1, 3, and 9. Okay. Our h is +2. Okay, using the opposite. And k is -4. K tells the truth. Okay. So for our domain, x is greater than 2. That deals with our x value. Y is all real numbers. Okay. And this is our log base 3 of x minus 2 to the minus 4. So we're going to translate. We're going to take our x value and add 2. Take our k value and minus 4. So 1 plus 2 is 3. 3 plus 2 is 5. 9 plus 2 is 11. 0 minus 4 is -4. 1 minus 4 is -3. And then -2. Okay. Graph these. So we know the vertical asymptote is now at +2. So 3, -4. 5, -3. And 11, -2. So it's doing something like this. Okay, this is the base function 1/3 to the y equals x. And this is our log base 1/3 x minus 3. So k is 0. And we have a +3, so x is greater than 3. Range is all real numbers. So 9, I'm sorry. If I plug in, whoops. If I plug in -2, -1, and 0. I'll get 1, 3, and 9. Translate. So I'm adding 3, and then I'm adding 0 to the y. So 9 plus 3 is 12, 3 plus 3 is 6, 1 plus 3 is 4, and these stay the same. And we know we're moving our vertical asymptote 3 units to the right. 1, 2, 3, so that's that there. So 1, 0. Or did I mess up? Oh, no, I'm looking at 1, 0. Okay, no, I'm supposed to be looking at this graph, right? After we translate it. 4, 0. 6, -1. And 12, -2. Alright. Hopefully this helps you out with graphing these. And I didn't even use a calculator whatsoever. And I will expect you not to use your calculator as well. Unless we have a crazy base. Which, like E, you'll now learn and you're going to have to use a calculator. Alright. And that is it for 7.4.